In the last video, we used Eclipse to set up separate compilation units, that is a .h file, .cpp file, actually two .cpp files. And we noticed that we kept these things and we kept parts of the program in separate files. We actually do compile them separately, and you can see that if you were to look in the console after you do a build, we set up this is something we started in the last video. We set up a main.cpp that uses a simple class a.h. Simple class a, and we pound include a.h to be able to use it. We don't so far right now, until we get to templates, we won't ever pound include .cpp files. There's a good reason for doing that, because remember what pound include does is if you were to have a .cpp file, what it would do is it would take the contents of this entire file, and it would notice, the C++ preprocessor would notice that this actually does a pound include itself. So then it would first go and get the a.h file, take all of the contents, put it into a temporary file that's just like a.cpp, and then take that temporary file, and if you had a.cpp here, it would take the contents of this entire file, which includes a.h2, and put it in here. So that's not needed, and it's actually going to be a waste. It's going to a waste of time, because what it'll do is it'll compile this the system will compile this a.cpp file, and you can see that here. Here it is, building a.cpp, and here is the compiler, G++. It's compiling a.cpp. Alright, but then later on it'll compile the main.cpp file too. Now if you pound include a.cpp, it's going to compile it once for this file, and it's going to compile whatever code you have here. It's going to get compiled again because it's going to be pound included here. That's just a waste. You're just doing some unnecessary compilation. Also, oftentimes what will happen is if you are developing some proprietary code, you supply your client programmers with only the .h file. The .cpp files are compiled and not actually shared with anyone, because that's your source code. It has some valuable stuff in it that you don't want to reveal. That's actually usually compiled into a dynamic link library or a static library, and then all the client needs is the library files and the .h file. So another thing that you do is you hide as much of the details as possible from the client. That is, you put very little detail in here. You try to hide it all in here, and this file is not sent out. This is only compiled into a library program. Library file that you then send to the client. So there is some information hiding that happening here, and that's a good thing. Remember that with encapsulation, one part of encapsulation is bringing together all the things that's associated with the real-world object into one class, rather than spreading data about an object among various classes. Bring it together. The other thing is to hide as much of the implementation details as possible. So that's why all of this is tied in with encapsulation. You only reveal as much information as you want your client programmer to see, even if that client is yourself. Even if you are using some of your own files, you want to hide as much of the detail as possible away from whatever is going to use it. In this case, it's very simple. But okay, so back to this. You don't want to use .cpp file, because for one thing, you may not have a .cpp file. Another thing is you may not want to reveal details of the implementation of this A class to a client. And so if you do, the client may be able to do unsafe things. So for those reasons, always, for now at least, until we get to templates, only pound include .h files. Alright, and so these things are compiled separately. You compile the a.cpp, you compile main.cpp, you do not compile a.h. And you might say, well, what happens to this? Remember, the pound include takes all of this code, puts it in wherever, puts it in here, puts it in here. And so it is compiled, but not as a separate compilation unit. It's just, all you do is very, in a dumb way, you copy all the contents. That's what pound include does. It copies all the contents of that file into here. And so when you compile, yeah, you actually do see this. But you just, what you do is you just pretty much just copy it into here, and then you compile this file. You can, if you really want to, you can compile .h files. There's nothing stopping you from doing that. And you can call this, for all this is concerned, you can reverse the names. You can call this .h file. You can call this .cpp file if you want to. Nobody does that, but C++ would let you do that. And you could compile this file. Whether it's whatever it's called, doesn't matter. If you really want to, you can actually compile this. There's, you don't get any benefit from doing that. So Eclipse, when you go through the wizard, it sets up a lot of things very nicely. It even makes sure that it knows that it doesn't have to compile this. It only has to compile the .cpp files, the main and the a.cpp, where all the method bodies are located. So it tries to help you, tries to minimize the amount of work that the compiler will do, sort of makes things faster as much as possible. That said, you can get into all kinds of trouble by changing things around. Okay. So that's the idea. Compile all of those .cpp files separately, and then link them together before the program runs. That's usually what's done. So the language doesn't actually check all of these things, unlike the case of Java, where you only have .java files. And then when you compile them, you create .class files. You don't actually link them together into one big executable file, like as what happens with C and C++. So C and C++, you generate an executable file after everything is linked. Okay, so you want to be aware that there's class definitions and declarations. This is separate from the using programs. You can, for example, build a whole library of classes that are going to be reused. That is, you don't have to reinvent the wheel every time you need to. For example, you need a square class that represents a square. You can write it once and then have it be reused by many programs. Okay, so you want to separate your classes. You want to make sure that they're independent. Later on, what we'll see very soon is that you can set up classes that use other classes, and where there's a lot more interaction between classes. But for now, we want to keep them as separate as possible. So that's why we use a .h file. So the class definition or class specification is called the interface, and then all of the methods, the functions, member functions, are in a separate class implementation file. The C++ does not enforce this, so you could do everything in a .h file. And then you could compile the .h file if you want to. And people try not to do this. Why? Because most C++ programmers will expect you to set up separate files. That said, you don't have to stick with that convention. One of the other things that's nice is that when Eclipse sets up the steps needed to compile programs, let's say you add a new data member and you only need to change a .h file, right? So let's say you do something like this. You say you add a new data member, private int data. All right. By saving this, notice that when you compile it, let's take a look over here. Let's just clear this. All right. Let's clear that, And then what we'll do is we'll compile this. All we did was change a .h file. But notice, if you were to do this in Eclipse, it compiles the .cpp file. Why? Because you pound include it. You pound include a.h in .cpp file. Even though this hasn't changed, just because you change this, you might be changing something about the way this class behaves, so it recompiles a.cpp. Also, it recompiles main.cpp. Why? Because you pound included it. So Eclipse sets all of these dependencies, that's what they're called, all these dependencies up for you so that you don't have to worry about what to compile when you change something. In this case, you might see this warning. Since you added this int data member, you get a warning basically saying that you need to initialize this, and you can just do something like this and take care of that warning. Okay, and it recompiles. This time around, it compiles the excuse me. Notice it compiles the a.cpp file. Does not compile the main.cpp file. So I'm paging through. It's kind of hard to see. You might want to try this on your own in Eclipse. When I change the a.cpp file, unlike the situation where I changed the a.h file, where if you change the a.h, because a.h is included, it has to recompile this, If you change the a.cpp file, Eclipse has set it up so that it knows now it doesn't have to compile main.cpp again. All it needs to do is recompile this, because it doesn't affect, nothing in main.cpp has been affected by this change. And so it recompiles a.cpp, and then it does the link step. And you can see invoking Mac OS X C++ linker. Okay, which is actually just the same program, but it's used in a link phase. And then it creates an executable out of the existing main.o and a new a.o object code. Creates a new executable, like 13. Okay, so that's what this means. If the implementation changes, that is, if you change if you change a.cpp, only that file needs to be recompiled. So the book uses the word user. Excuse me. The book uses the word user to mean the client program, whatever client main function or client class. So if you change your class, the client classes do not need to be recompiled. All those .o files can be just linked in to create new executable. As a quick review of encapsulation, these are things we look at in CSIS 235, and when we look at Java, the basic idea is we want to look at how the class is used by the programmer, keep that view in mind, and also separate that from the details of how you would set up the class. So for example, let's say you set up a class that keeps track of a list of strings. You should write this class in such a way that the client should not care at all whether you use whether you use an array or a vector, or later on we'll use linked lists and things like that. The client, or the way the client sees your class, or how the client is used, or how the class is used by the client programmer, that should not matter with no matter what you do with the way you implement the class. Okay, so in C++, this separation is really explicit. So if you change it from an array to a vector internally, it should have no impact on any other programs. All the other programs, all the other client programs should still work. This is a basic object-oriented principle, and I'm hoping this is clear. We've used this in the past. Now in C++, this will be even more explicit because we have the .h file and the .cpp file. The client program should never see the .cpp file.